Morning, 6th grade. Welcome to Tuesday, lesson 9. Hopefully you got your power up and your quiz all done. We got to practice power up A only a few more times, and you're going to get that on the test this Friday. So make sure you got your multiplication down and you know your answers really well. And then you're still cranking on your quiz. I'll start by going through your problem solving. They had a picture of a ruler with a coin on it. It says this: the diameter of a circle or circular object is the distance across the circle through its center. Find the approximate diameter of the penny shown at the right. So they have a ruler, they have a penny, and you're trying to figure it out. Now what I'm tempted to do is measure to here and say it's 1 1/4 inches. But what I have to realize is it didn't start at the 0, it started as I counted in at the 1/2. Now there's a few ways to do this one. I think the easiest is to just count tick marks. So I would have counted the spaces, or I remembered from Monday that we take a ruler, we divide into 16. I'm just going to count tick marks. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And I could have written my answer, it's 12/16 of an inch. That might bother some of you because you're going to say, Mr. Bauer, we can reduce that. Yes, you can, but this year, guys, I haven't taught you that yet. So if I haven't taught you it, you don't have to reduce it until we actually teach you the lesson. But that reduces down to 3/4 of an inch. Would have been a great answer. This would have been a good answer. You could have done math, which would have been really hard, because to subtract 1 1/4 from 1/2, we'd have to find common denominators and then borrow. We haven't taught you any of that stuff yet. So I think the easiest is just to count. Now, the takeaway from the problem solving, guys, is they're giving you a vocabulary word. Distance across the circle is called a diameter. Quick review from yesterday. Yesterday we were talking fractions, percents, parts of a whole. Remember, number 1, when I divide something into fractions, the parts need to be equal. Bottom number, denominator. How many equal parts are there? Top number, numerator. How many of the selected things do we have, whether that's shaded or not shaded? Percent always means out of 100. Pound that into your head. We're going to continue to use it as we continue to work with percents. And then yesterday we ended with that inch ruler. We just got it reviewed. Remember, page 56 is a great reference. Today we're moving on. We're talking about adding, subtracting, and multiplying fractions. And then we're going to mess with reciprocals because we need reciprocals when we divide fractions. Today in lesson 9, it's going to start with common denominators. In a couple more weeks, we will move to uncommon denominators. That takes a little bit more work. Hopefully your yellow folder's there and you're ready to rock and roll. There's not too many blanks to fill in, but a decent number of points of interest. Here we go. It says on the line below, AB is 1 3/8 inches and BC is 1 4/8 inches. Notice they didn't reduce that, guys. They didn't say it's 1/2, they said 4/8. We can find AC by measuring or by just adding those two together. When adding fractions that have the same denominators, we add the numerators and write the sum over the common denominator. And so, guys, we have to have common denominators to add and subtract. You always will today. So if I'm looking at my yellow folder, you can see I put that stuff in there. Must have common denominators for addition and subtraction. Add the numerators and the denominators stay the same. Subtract the numerators and the denominators stay the same. So don't add those bottom numbers together. 1/4 plus 1/4 is 2/4. It's not 2/8. That would be right back to where I started. Okay, let's work a few examples. A says 1/7 plus 2/7 plus 3/7. I add my numerators. 1 plus 2 plus 3 is 6. The 7 stays the same. This time we switch to percents, but it's the same thing. We have a fraction of a percent. 1/3 plus 1/3 is 2/3. 33 plus 33 is 66. That's 66 2/3%. They're teaching you what's 1/3 plus 1/3, 2/3. What's it as a percent? 33 1/3, and 33 1/3 is 66 2/3. B, it says how much money is 1/4 of a dollar plus 3/4 of a dollar? 1/4 plus 3/4 equals 4/4. Anytime we have the same fraction over each other, we equal it to 1. So 4/4 equals 1. I have 1 whole dollar. No one says, how much do you have? I have 4/4 of a dollar. That's just not how we speak when we're in the world. And so we convert 4/4 and write the number 1. In between example 2 and 3 gives you a line on subtraction. To subtract the fraction from a fraction with the same denominator, we write the difference of the numerators. The denominators stay the same. So then they give you 2 examples of that. The first one is mixed numbers. Notice with the mixed numbers, guys, I wrote it up and down to do the math a little bit easier for myself. 5 minus 1 is 4. 9 stay the same. 3 minus 1 is 2. Problem solved, 2 4/9. Last one, I have 3/5 minus 3/5. If you're doing the thing, you would say 3 minus 3 is 0. The 5 stays the same, but once again, guys, we don't call it 0/5. We just call it 0. So my answer is 0. Now let's learn how to multiply fractions. It says the first illustration shows half of a circle. The second illustration shows half of a circle. We see that 1/2 of a half is a fourth. We often translate the word of into a multiplication symbol. We find 1/2 of 1/2 by multiplying. 1/2 times 1/2 equals 1/4. Here's how you do it. To multiply fractions, we multiply the numerators to find the numerator of the product. We multiply the denominators to find the denominator of the product. Notice that the product of the two positive fractions less than 1 is less than either fraction. So when I'm multiplying two fractions together, the answer is going to be smaller than what I started with. Also notice, guys, because you're multiplying the top and the bottom, you do not need common denominators when it comes to multiplication. So you have that in your bullet notes, multiply the numerators and the denominators, and then pound into your head. Of means multiply. We're going to get a ton of word problems this year that uses the word of, and we need to be able to translate that to the multiplication sign. Turning the page, we got a few examples for number 4. First, A is the word of. Of means multiply, so I simply do 1 times 1 is 1 and 2 times 3 is 6. Problem solved. Next time they had 3 fractions, making it a little bit more fun. We can do that with multiplication just like we can do that with addition. I go across the top. 1 times 3 is 3 times 1 is 3 still. Multiply across the bottom. 2 times 4 is 8 times 5 is 40, and I got an answer of 3/40. Now guys, neither one of those can be reduced, but remember, if you ever get one that can be, you don't have to do it yet, but they give you very few of those that actually have the ability to reduce those. Okay, last part of our lesson is reciprocals, and a word that goes along with it. If we invert a fraction by switching the numerator and the denominator, we form the reciprocal of the fraction. The reciprocal of 4/3 is flipped over 3/4. The reciprocal of 3/4 flipped over is 4/3. The reciprocal of 1/4 is 4/1, which is 4. Therefore, the reciprocal of 4 is 4/1 is 1/4. Note the following relationship between a number and its reciprocal. The product of a number and its reciprocal is and always is the answer 1. And so, guys, that's your notes. You got your definition of reciprocal, and then you got the inverse property of multiplication that we'll get to down there. It says here we show 2 examples of multiplying a number by its reciprocal. 4/3 times 3/4 is 12/12, which equals 1. 1/4 times 4/1 equals 4/4, which equals 1. This relationship between a number and its reciprocal applies to all real numbers except 0. It's called the inverse property of multiplication. They gave it to you in letters there. I like that. A number times its reciprocal equals 1. And so your math book will give you questions. Think of a number. Multiply by its reciprocal. What's the answer? And so often 6 years ago, Mr. Bauer, how does your book, which gives the answers, know what I'm thinking of? It doesn't matter what you're thinking of. Any number times its reciprocal equals 1. So make sure you fill in your blanks in your notes with the answer of number 1. But we're going to use that reciprocal property all the time. Now, guys, I like to use the word flip. What'd you do? You flipped it over? But that's not really speaking math. The correct term is reciprocal. What are you doing when you have the reciprocal? You are inverting. So invert flips it over. That's why it's called the inverse property. It's not called the reciprocal property. It's also not called the flip it over property. It's called the inverse property. Let's put it to work with example 5. Example 5 says, find the reciprocal of each number below, then multiply the number and its reciprocal. So I start with 3/5. What's the reciprocal? 5/3. When I multiply them together, what's my answer? I'm not doing the math. It's always 1. Okay, now they gave me the number 3. This is really 3/1, if that helps you guys. Any number over 1 is that number. So what's the reciprocal? 1/3. What's it when I multiply them together? It's 1. The inverse property tells me that. So now when you get to those steps, sometimes they say, hey, let's do math. You got the commutative property, you got the associative property. Lots of times now they'll mess with fractions and stick in the inverse property of that. Number 6 says, find the missing number. 3/4 times, I don't know, equals 1. Anytime you equal 1, you flip that guy over. So it's 4/3. Now they'll give it to you in word form, guys. That's number 7. How many 3/4 are in 1? how many, I don't know, 3 4s are in 1? That's taking number 6, guys, which was just a math problem, and switching it to a word problem. The answer is the exact same thing. It's the reciprocal. And so they're teaching those things. Then they'll build on that, guys, and they'll say, if there are 4/3 in 1, how many are in 3? And then we'll just take a next step and we'll multiply those together. Okay, underneath it, it says this. In lesson 2, we noted that although multiplication is commutative, 6 times 3 equals 3 times 6, division is not. 6 divided by 3 is not the same as 3 divided by 6. Now we can say that reversing the order of division results in the reciprocal quotient. So if I know it the one way and I get my answer, I can just flip it to get it the other way. So we know 6 divided by 3 is 2, so what's 3 divided by 6? 1/2. And so that's all they're trying to teach you as they go through that. You got that practice set on the bottom. Feel free to look at some of those things so you can see what they're doing with that. There's one more thing I want to show you what they're going to give you in the future, but I want you to be prepared for it, and that's when they do this for you. I have 3 1/4, and they say find the reciprocal of that, guys. We're going to have to learn how to make this into an improper fraction first. Now that's coming up down the road, and I'll show you that again. But it's not just flipping the fraction, it's changing this whole thing. And so get prepared for this into the future. It's not coming in any of your lessons right now, but into the future, I have to switch that to an improper before I flip that thing over. Okay, we'll work some problems. All right, 6, lesson 9's problem set starts with a number 5. Number 5 says a dime is what fraction of a dollar? Well, I know a dime is worth 10 cents. I know a dollar is worth 100 cents. So it is 10/100ths of a dollar. I like to cross out those zeros and say it's equal to 1/10. B says a dime is what percent of a dollar? Well, remember, percent means out of 100. What did I write on top? I wrote that 10 on top. Now 10 goes into 100 10 times, so 1/10 is 10% of a dollar. Number 9 says list the factors of 18. I'm going to try to put them in order. So I have 1 and 18. I have 2 and 9. I have 3 and 6. Then it says list the factors of 24. That equals 1 and 24, 2 and 12, 3 and 8, 4 and 6. I'll put my commas in. C says which numbers are found in both of those. So for letter C, I can see I have 1. I can see I have 2. I can see I have 3. I can see I have 6. And that's all I can see. D says what is the GCF of 18? That's the biggest number here. That's 6. GCF, remember, stands for greatest common factor. Number 11, find the value of each variable. Missing something in addition. I subtract 200,000 minus 85,000. Zeros come straight down. This becomes 1910. That's a 511, 115,000. Number 12, missing the divisor in division, I still divide. So I have 900 in the box divided by 60. Feel free to cross off a 0 if you want. I'm going to go 90, 60 goes into 90 once. Bring down. 60 goes into 300 5 times is 300. And I get an answer of 15. Number 13, missing the first in addition, doesn't matter. Missing anything in addition, I subtract. So I have $20 minus $5.60. 0, can't do, becomes 19 and a 10. That's a 4, decimal point straight down. 9 minus 5 is 4. 1 minus nothing is nothing. Ooh, that's an ugly dollar sign. $14.40. Number 14, missing something in multiplication. Missing in multiplication is once again a division problem. So I'm doing $30
divided by 12. Now, it was nice that they gave me the decimal point and the 2 zeros, guys. In the future, they won't. You'll have to add those in. 12 goes into 30 twice. Multiplied is 24. Subtracted is 6. Bringing down the 0 goes in there 5 times. That's 60. Subtracted is 0. Bring down the last 0. It goes in there 0 times. My decimal point goes straight up, and I add my dollar sign. It's $2.50. Number 15, missing the first in subtraction, I add. Remember, the S's go. Second still subtract, so first means addition. So I got $98.03, and I'm going to add to it $12.47. 3 and 7 is 10, 1 and 4 is 5, decimal straight down. 2 and 8 is 10, 1, 9 and 1 is 11. I have $110.50. Flipping over your answer key, you're up to number 17. 17 is subtraction. 3 and 11/15 minus 1 and 3/15. I'm writing them up and down. They'll help in the future. I subtract the numerators. 11 minus 3 is 8. The denominators stay the same. I go back to my whole numbers. 3 minus 1 is 2. I have 2 and 8/15. Number 18, this time I'm adding 1 and 3/8 plus 1 and 4/8. Notice that they're not giving it to you in reduced form. That's coming up. 3 plus 4 is 7. 8 stay the same. 1 plus 1 is 2. 2 and 7/8. Number 19 is a multiplication. This one I think is easier to write side by side, and we'll learn that in the coming up future. Multiply the tops. 3 times 3 is 3. Multiply the bottoms. 4 times 4 is 16. And I have 3/16. Number 23. Another multiplication problem. This one's a little bit longer. 4/5 times 2/3 times 1/3. I was writing dots there. 4 times 2 times 1 is 8. I'm going to go backwards. 3 times 3 is 9, times 5 is 45. Kept it as single-digit multiplication by going the commutative property on us. You certainly could have done 5 times 3 is 15, times 3 is 45. I thought it'd be easier. Number 24, 1/9 plus 2/9 plus 4/9. Add the top. 1 plus 2 is 3. 3 plus 4 is 7. 9s stay the same. Keep stressing that in your head so you don't get confused and write down 7/27. Number 25. Write the steps of and the properties that make this multiplication easier to perform. So I have 50 times 36 times 20. Okay, now here's what I'm going to do. This is what I was given. So the first thing I want to do is I want to put numbers I can multiply together. So I'm going to do 50 times 20 times 36. I changed the order of these two. That's the commutative property. Then I'm going to do, hey, let's actually do the multiplication. 50 times 20 times 36. So whoop, I'm going to put them into the parentheses and say, let's do this multiplication. I grouped them. That's the associative property. And then you would say 50 times 20 is 1,000. 1,000 times 36 is 36,000. Now, that's just multiplication, guys. So you just need this step and this step. But they're trying to teach you, hey, we can do these things in our head if we think. Why are we allowed to do that? That's reviewing those properties. Next one is number 27. Lines AB and lines XY lie in different planes. Which word best describes their relationship? Intersecting, skew, or parallel? Now, there's a couple ways to do this one, guys, for number 27. Number one, I could look at A intersecting and say, if I look at that, those lines will never intersect because they're in different planes. I could look at letter C and say, those lines are definitely not parallel. They're not side by side. So my answer has to be B. That's a skew line. Your other choices, you'd have to remember to go back to lesson 7. If I turn back to lesson 7, and you have a really good memory, you'll remember when we did that example on page 50, Example 6, I said, hey, remember that blue term of skew lines? It's going to come back, and here it is. It came back for you in number 27 there. So you have a drawing that gives you skew lines. Skew lines are lines that are in different planes. They'll never touch, they'll never intersect, but they're also not parallel. That's something that only happens when we have different planes, guys. Last but not least is number 30. Number 30 says how many 2/3 are in 1? This would look like this as a math problem. How many? I said 2/3. How many 2/5? 2/5 times, I don't know how many, so I put in a letter, equals 1. That's the inverse property from today. A number times its reciprocal equals 1. So n, flip that guy, gives me 5/2, and it just stays like that. You'll learn way later on in math class that this is algebra when we have letters, and anytime you mess with algebra, you leave it as an improper fraction. You do not switch that back. You got the 15